Hi everyone, this is Chem Interview. Here we talk with the most prominent and influential representatives of chemical science and industry. And today our guest is the professor of the UCLA, the University of California, writer and the philosopher of science, Eric Sherry.
Hi.
Thank you very much that you join us today. And maybe first question just from the scratch. What is actually the philosophy of chemistry? What are the main issues addressed in this kind of field?
Okay. Well, thank you for this invitation. Let me attempt to answer your question. Philosophy of science has traditionally been about philosophy of physics, because physics is regarded, and it is the most fundamental of the sciences. And it raises philosophical issues about space and time and simultaneity and determinacy. So it was natural that philosophers should concentrate on physics. And then when it was realized that there was a bit too much attention on physics and not enough on the other sciences, philosophers of science turned to the other extreme, if you like, and they developed a philosophy of biology. And still, chemistry, which is the so-called central science, was largely ignored. And chemistry was regarded as a service industry, a practical science, but of no great philosophical importance. Now, in the mid-1990s, some of us began to write articles trying to explain that actually chemistry does have some philosophical ideas. It has some big ideas, if you like, and that it is worthy of philosophical attention. So the philosophy of chemistry began in the mid-1990s. The kind of issues involved are, the main one has been the question of reduction, because it was popularly believed that chemistry is nothing but physics, and that the answers to complicated questions or any question in chemistry would be found in theories of physics, especially quantum mechanics. So one question in the philosophy of chemistry has been, to what extent is chemistry nothing but physics? Philosophers call this the question of reduction. Does chemistry reduce to quantum mechanics? Now, the answer is complicated. Broadly speaking, yes, it does. But it's interesting to ask, to what extent does it reduce? Does it reduce fully to quantum mechanics? Is the explanation to everything in quantum mechanics? Of course, the answer is no. It's a more subtle relationship than yes, no. Another issue related to this is the question of molecular structure, because it turns out, rather curiously, that if you consider two isomers of, for instance, ethanol, C2H5OH, and dimethyl ether, CH3OCH3, they have the same molecular formula, but in quantum mechanics, the Hamiltonian for these two molecules is exactly the same. And so quantum mechanics cannot distinguish these two isomers, which seems like a strange situation. It can only distinguish the two isomers if we put information in by hand, if we fix the nuclei, if we apply what's called the Born-Oppenheimer approximation. But without that, so pure quantum mechanics cannot distinguish between those two isomers. Some people in philosophy of chemistry take that to mean that chemistry somehow emerges from physics, that it's more than the sum of the parts. I happen to disagree with that view. I don't believe that there's emergence in this sense. So there is a debate about emergence, yes, or not emergence. The alternative view is that this is just an example of a question that occurs in foundations of physics. In foundations of physics, one of the big issues is the collapse of the wave function. For instance, there's a well-known thought experiment which aims to explain this. It's the Schrodinger's cat experiment. You have a cat that's put inside a box, a sealed box. You have a radioactive isotope, and you have a container full of poison. Now, radioactive isotopes will either break this container and release the poison or will not. Radioactivity is a very on and off sort of phenomenon. So the cat will either die because it will be poisoned, or it will not die because there hasn't been a release of the. According to quantum mechanics, we have to say that the cat is both alive and dead simultaneously. This is because in quantum mechanics, one speaks of superpositions rather than actualities. So we have the situation where, intuitively speaking, we think the cat is either alive or dead. Quantum mechanics doesn't allow us to even ask such a question. Quantum mechanics says it's both alive and dead at the same time until you open the box, and then you discover if it's one or the other. So some of us, including me, believe that the question of molecular structure, which I was just telling you about, is of that kind. When a molecule is first formed, it doesn't have a definitive structure. It is a superposition of both isomers. And then very quickly, there's something called decoherence, quantum decoherence, which takes place. And so it actualizes into one or other of those two molecules. Now, the details remain to be worked out. There are some people who are actually working on this issue. So that's one of the many topics that exist in the philosophy of chemistry.
As far as I understand, there is a kind of subfield in the philosophy of science, philosophy of chemical science, which is the history and philosophy of the periodic table.
Right.
Wanted to ask you what kind of field is that, and what are the main problems there, and why we should actually study this field.
Okay, well, now the periodic table, the popular story, if you like, was that one day back in 1869, Mendeleev, the great Russian chemist, had a dream, and it occurred to him that one should design a periodic table. So he woke up and he just wrote down the periodic table. End of story, more or less. In fact, the history is far, far more complicated, far more nuanced. There are contributors going all the way back. You know, first of all, the identification of elements, and then the realization that some elements behave similarly to other elements, and then early periodic tables. But even if we consider mature periodic tables, there are as many as 6 co-discoverers of the periodic table. So that's the historical aspect of history and philosophy of the periodic table. On the philosophical side, we can ask the question, what is this mysterious property that as we move through the elements, every so often there is an approximate repetition, like lithium, sodium, and potassium? I mean, modern physics goes a long way to explaining this, right, in terms of electron shells and configurations. But still, it is a remarkable situation that there should even be such a property of repetition as we walk through the line of elements. The philosophy of chemistry asks questions about, is the periodic table a law? Is it a theory? Is it a classification? What is the relationship? Does it explain? Does the periodic table itself explain things? Or is it explained by quantum mechanics, which of course is the more accepted view? And it's a central idea. It's one of those big ideas in chemistry. Chemistry doesn't have many big ideas. The periodic table is perhaps the biggest idea in chemistry. It is a central unifying concept, unlike anything that one finds in physics and biology. Doesn't have one central unifying chart that brings everything together like that. So that's a brief answer to your question of why we should be interested in history and philosophy of the periodic table.
And you are a unique person in the sense that you are a big expert in 2 fields which seem to be not really similar, because you are on the one hand a chemist, and on the other hand you are a philosopher, or even history expert. Wanted to ask you, how is it possible, and is it actually a common rule that an expert in humanities and an expert in natural science can coexist in one person?
Well, to be strict about it, I am a chemist, but I'm not a practicing chemist. I don't make molecules. I don't do computations on molecules, but I do research in history and philosophy of chemistry. So I'm looking at the broad picture. But yes, I am in both fields at once. My PhD is in history and philosophy of science. That already implies that there are many people who straddle both fields, who are both humanists and scientists. I was first a scientist. I came to philosophy later on in life. In my PhD, my undergraduate and my master's degrees are in chemistry. So yes, there are many people who straddle the two sides, if you like, the humanities and the sciences. And why not? I mean, originally, all scientists were philosophers and philosophers were scientists. And everyone has an interest in both sides. It's just that specialization makes it that people tend to do one thing or another. But I think it's enriching for everyone, for the individual and for students, for example, for studying science. It's a very, very enriching and enlightening to have an interest in both aspects. I always try and tell students that if they understand a bit of the history of how a theory developed, then they can get a more appreciation for that theory. You know, if they think more deeply about the theory instead of just learning it or superficially just, you know, solving numerical problems, if they think deeply about it, if they adopt a philosophical attitude, then it will reward them in that it will make the study of the subject more enjoyable.
Absolutely, and I agree with you. The next question would be, you also are an author, you write non-fiction articles for many journals like Scientific American, American Scientist, New Scientist, Chemistry World. Maybe you could tell us a few words about this area of application of your knowledge, because it's also interesting potentially for young students today. What kind of person, which personality features one should have to be a good storyteller or to write such non-fiction articles?
Sure. Well, first of all, chemistry needs better public relations. Chemistry needs popularization. There is a lot of popularization of physics. There's a lot of popularization of biology. But again, you know, it's a bit like I was saying before about the philosophy of chemistry. Popularization of chemistry is not very well developed. So it needs people like myself and yourself, you're a science journalist, to explain chemistry to the general public, to explain to the general public that chemistry is not just about pollution, and it's not about, you know, as the common expression, does this food contain chemicals? Which is, of course, ridiculous, right? But so chemistry has a bad name in the general population. So it needs popularization more than many of the other sciences. Now, I choose to do it through the historical and the philosophical aspects of chemistry. So yes, it's a form of popularization. I enjoy doing it. I enjoy writing for a broad audience. And I think, you know, more people should do it. There are not enough people writing popular chemistry articles.
And you said that chemistry has a bad fame. I think you said the other word, but still, why?
Oh, because of pollution, because of, you know, it's regarded as the source of all evils. And as I was saying, you know, this expression, are there any chemicals in this food? Of course there are chemicals. Everything is a chemical. But, you know, so it's the idea that chemicals are bad right from the outset, which we all know is nonsense, but it persists in the general population. In fact, chemistry is a science which is practiced by huge numbers of research scientists all over the world. It has contributed tremendously to technology and development and health sciences and what have you. And people should become aware of the benefits of, and the sheer intellectual interest in a science like chemistry.
You have written many books. One of them is called A Tale of Seven Scientists.
Yeah.
There you write about lesser known chemistry scientists who haven't made any big discoveries, but still they have done some input to the science.
Yeah.
And the fact that only the greatest are remembered, and always not, also not always, even the greatest are remembered. Will it be always like that? And also, in your opinion, how does the collective memory itself should work and works actually in the field of chemistry and science in general?
Okay. Yes, of course, in society, everybody likes a winner. You know, in sports and in all activities, we laud, we appreciate the winners, the people who are in science, the discoverers. But that neglects the fact that in addition to the main discoverer, or the one who's recognized, there are so many other people who have contributed to that discovery. Because whenever one makes a discovery, it's because of some previous work. No discovery occurs in a vacuum. No discovery occurs in isolation. So in that book that you mentioned, A Tale of Seven Scientists, I mentioned what I call the little people, the people who go unrecognized, but who have contributed. You take any scientific discovery and you look into the past, and you will find that there's somebody who nearly had the correct idea, or who had the correct idea but didn't publish it, or who published it but published it a little bit too late, and so on. So yes, we want to keep on rewarding the winners. I'm not suggesting we should, abolish Nobel Prizes or anything like that, but we should also accept that science is a cumulative and collective endeavor, a collective process. And I don't necessarily mean a collective process in the sense of big teams of scientists. Of course, that happens more and more in science. But I also mean it collective in an unconscious sense. For example, the phenomenon of multiple discovery in science, when 2 or 3 or 4 scientists in different parts of the world arrive at more or less the same time at the same discovery. Okay, and that often leads to priority disputes as to who discovered it first. But just the fact that that happens time and again suggests maybe something deeper. Maybe it suggests, and this is what I argue for in the book that you mentioned, I call it Sci Gaia, Science Gaia. Now, I don't know if you're familiar with the idea of Gaia. It was a concept developed by a British scientist. His name is James Lovelock. He has the idea of the Earth as a unified living organism, which he called Gaia. So it's one entity. So I'm proposing that although scientists are all running around individually conducting their research, if you look at it from a sort of Olympian height, what you really have is like a beehive, where all the bees are working for the sake of the hive, even though they don't know it necessarily. They may even think they're competing with each other. But what they're really doing is they're all working collectively. I'm a very strong believer in the unity of science. In fact, the unity of everything. My favorite philosopher is Spinoza, who argued for everything is one, far more than any other Western philosopher that I'm aware of. Spinoza had this unique idea. Oh, I mean, the idea is not unique, but he pushed it much, much further than anybody else. Anyway, I'm digressing, but it's all related. It's all related. The idea of the unity of science, co-discovery. And so in that sense, it's rather nonsensical to say this person discovered this and that person discovered that. Science discovered it. But of course, we need to take credit. We need to give credit to scientists. Otherwise, they wouldn't want to work, perhaps. People like prizes. People like recognition. So it's a paradox. We are individuals, but we're also members of a collective enterprise called science.
Speaking about this collective enterprise called science, you surely know there is kind of concept of the theory of everything.
Yeah.
But at the same time, we can see that many different scientific fields, they tend to split in something very different in various scientific disciplines, which have their own methods, theories, language, and so on. And as a result, the farther humanity progress goes, the more complicated it is to communicate for scientists from different fields. In this regard, do you think that the theory of everything is possible, or what we will have later will be, so it will end up with infinite number of different theories, which with their own methods?
Yeah. Well, of course, a theory of everything is possible. I mean, some people claim there already is a theory of everything, or almost a theory of everything. But I think it's a little too ambitious. I don't think there will ever really be a theory of everything, because everything is constantly changing. So as soon as somebody has written down the theory of everything, somebody else in another part of the world has discovered something new. And does the theory of everything keep pace with that new discovery? No, the person will have to go back and amend the theory of everything to include this new, completely new phenomenon. So for that simple reason, I think it's unattainable goal to have a theory of everything. Now, yes, you're right, because in a sense, science is branching into different areas and different areas. So that makes it even more difficult to achieve a real theory of everything. So I know that some scientists have claimed this. Stephen Hawking was one, Steven Weinberg is another one, and several people, several physicists have claimed that. So it's a theory of everything in principle. You know, it's a hope, but in practice, I don't, if there was a theory of everything, then it would put chemists and biologists and everybody else out of business, and the physicists would be doing everything because they have the theory of everything. They would have the theory of everything.